So today we're going to go over deploying mainframe code as well as distributed code in a single pass so we can keep everything packaged together. So basically keeping the mainframe components and the distributed components in sync. In order to do this, we're going to first start with the build step. The build step will execute on the distributed side as well as a build step that's going to occur on the mainframe side. From there, we will take those artifacts, check them into Harvest. We can use any repository. In this case, we're using Harvest. We could use Git, Subversion, a Maven repository, a file system repository. But that for today, the target repository is going to be Harvest. From there, we will execute the deployments from Harvest, pulling the artifacts from the package that we updated with our build process. So here's a picture of our flow that we're going to be utilizing today. So we're going to use Endevor as the source library. We're going to create the build output on the mainframe. From there, we're going to package together not only the load libraries that were built, but also some JCL that needed to be updated for our application to run correctly. From there, we're going to check that resulting XMIT file or library into Harvest, into the same package that we have for the distributed side. We're going to use Harvest as a source repository. We're going to build the source, which is going to be a EAR file. We're going to check that EAR file into the same package as the mainframe artifacts. So we have everything all packaged together. So we have the mainframe component changes as well as the distributed component changes in a single package inside of Harvest. From there, we'll be able to deploy out to our corresponding libraries, runtime environments. So we're going to pull the Harvest package, get the artifacts out of that Harvest package. They go into a drop zone for Releaes Engineer. And from there, the mainframe components will be set back up to the mainframe underneath a different user ID and then installed. Installing basically means creating the correct data sets, the correct libraries for the load library. So we get the right COBOL module in the load library, as well as creating the JCL control library. On the distributed side, on the Windows side, we are going to be pushing the EAR file out to our WebSphere environment. So we're going to deploy the EAR file out to WebSphere. So that's just a quick overview of the process. Let's go ahead and get started with just giving you a level set of where we are. So we have Releaes Engineer, which is running and which will be utilizing the deployment process. We have our application for our distributed WebSphere application. And if I go over to my TSO session, we're going to actually create two new data sets. So they're going to be called RE demo. There'll be a load and a control lib. So right now they don't exist, but as part of this build and deployment process, we will see those get created. So I'm going to go ahead on the mainframe here. Since I'm on it, I'm going to go ahead and edit my COBOL program. My COBOL program is going to be under an Endevor library. I'm just going to edit it directly. And here's my program. And we'll change this to say hello. All right, so that's going to be our source code change that we're going to build. And if we go over to our JCL, I'm going to update the JCL, the job card in the JCL. And here we're going to add the message class. So now I have updated the JCL as well as updating the COBOL program. So those are all ready to go on the mainframe side. I'm going to go ahead and go over to Harvest here, and I've set up some processes inside of Harvest. And the first one we're going to execute, like I said, this is a two-step process. First is going to be build and package, and then we'll go ahead and do the deployment. So I'm going to kick off my build process here. And we'll see our build kick off here in a second. So I'm actually executing this from our Windows machine through Harvest, and we're communicating with ZOS, Meister that's running on ZOS, that's going to actually do the compile step, the link edit, and then package together the resulting files so they can be then brought down and checked into Harvest. So we're going through the build process right now. So if I go over to our mainframe here, we can see that our jobs are finishing up. So what we have is we have the first two jobs are going to be Meister related. That's basically running Build, Make, and OM, which is taking a snapshot of the build of the KB server that's running on Windows for the creating the ZOS build control file. The next step is us submitting all the work that needs to be done as far as the next job to be executed. We did our COBOL compile and link edit, and then we went into our packaging, which is creating our XMIT file. And finally, the last step is some cleanup routines. So if we go back over to Harvest here, we can see that our version that we have right now is version 8. Now if I hit refresh, we have version 9 that's available. The last one didn't change because there's no changes. Harvest doesn't check in a new version if the contents are the same as last time. So here we've completed our mainframe build, and inside of our package we have the package we're actually using is binary update 2. We have our version 9. Now let's go ahead and do our build for the distributed side. So again, we're executing the build from Harvest. We're looking at the file system on the Windows file system to execute the creation of a ear file. And right now that has been completed or nearly complete. And we'll go back over to Harvest and we'll see when I refresh again, we'll see 38 should change to 39. So here we have on our build process, we've built the mainframe ZOS components for LoadLib and the JCL, and then we went and executed a separate build and packaging for our WAR file. Now let's go ahead and execute our deployment. So I'm going to deploy the contents of this package. So I'm going to deploy the WAR file, the control XMIT file, and the load XMIT file. And the deployment is actually occurring through OpenMake's Releaes Engineer. So if we go over to Releaes Engineer, and I believe we've packaged together this one. So here we have two components. One is the WAR file, which we're pulling version 2 from. That component is being checked out of the Harvest repository. The second is the mainframe component that includes the load and the control file. So these two are bundled together in our application. So we deploy at the application level. If we don't want to do it at that level, we can also create what we would call a release. At the release level, I'm pulling together two different applications as well, instead of two different components. So I'm pulling a dictionary application for Harvest that's coming from Harvest, and a dictionary application coming from ZOS. For ZOS. If we go back to what we deployed, look at our history here. We can see that version 39 was checked out of Harvest, and that was the war file. Version 9 of our control file and version 9 of our load was checked out. These get placed in a temporary location, a staging location for us to be able to push those up to the mainframe from. If we look at our log, we first went through and did our interface with WebSphere. So this is us updating WebSphere. And then at the very bottom is us transferring the control and the load libraries up to the mainframe for them to be installed. So here's uploading and installing those two libraries. So if we go back over to TSO, we'll see that we have one more job, and that was the upload job. If we go to 3.4, and remember when I first started this we were looking at this user ID P390A. We'll see that we have two new libraries, and let's go ahead and view this one, and we can see over here that we have our message class that we added. I'm going to go ahead and submit this for running. And we'll go over to and this is our very bottom one is the one we just submitted. We'll select that, and we can see this is the output from our COBOL program. So this JCL is running the COBOL program that we updated. So on the mainframe side, we have deployed from Harvest the control, the JCL, as well as the load library. If we go over to our WebSphere page, remember we started with version 1. Let me go ahead and refresh that, and now we have version 2 that's available. So just to recap, we took our source code change, built it using Meister for ZOS, which packaged together the ZOS components and enabled us to add those artifacts to the Harvest repository. On the distributed side, we had our source code change that we have. We pulled that, built it, which was a WAR file, and that WAR file was packaged together, it was placed in the same package. So that was the first step of our process, was the build step. The deploy process then was pulling the artifacts out of Harvest, putting them in a drop zone that Releaes Engineer was able to pull to create, and then we pushed the corresponding components to the right location. So the mainframe components went to ZOS and got installed into the correct libraries. And then on the distributed Windows side, we pushed the WAR file out to WebSphere and restarted WebSphere accordingly. One thing you can notice is that we've executed that everything from inside of Harvest. So Harvest in this demo was the control point for doing the deployments, the builds and the deployments. Other tools can be utilized as the central control point. Meister itself can be the control point for doing the builds and scheduling the execution through Releaes Engineer. Other products like RTC, Subversion, and Get, any of those, or file systems can be utilized instead of Harvest. Thank you very much. And if you have any questions, please contact us. My name is Steve Taylor. I can be found at steve.taylor@openmakesoftware.com.
Thank you for watching our online videos. OpenMake Meister and Releaes Engineer comes with easy entry pricing. You can download a team version for free, and a team version supports 2 applications. An application is a complete package that is either compiled as a unit or deployed as a single unit. And it can include many components, database updates, or even OS level changes. More than 2 applications, we charge $1,000 per application per year on a subscription basis. And yes, we support a perpetual license when requested. You can start today by downloading either Meister or Releaes Engineer from GitHub. You can also open support issues at GitHub. For more information, you can go to openmakesoftware.com or email us at request-info@openmakesoftware.com. Thank you.